Alrighty. Good morning. Happy Tuesday. This is April 21st. This is AP Computer Science A. Hopefully everybody's having a fantastic start to your Tuesday. Today, what I would like to do with you is I would like to go over the answers to the two free response questions that I asked you to do. I would also like to talk a little bit more about your final project because that is still a thing that's looming on the horizon. That's still an expected task of you. It is, in fact, a mandatory task for the College Board's curriculum for AP Computer Science A, so it is something that you do have to do. All right. Um, but I want to talk about that a little bit more and just the structure of the class as we now progress into the fourth quarter. Hopefully everybody saw, actually I know everybody saw that your grades had been posted for the third quarter. What was I going to say about that? Oh, the grades have been posted for the third quarter. The way that fourth quarter grades are going to work, you probably are already familiar with the fact that they are all going to be equally weighted. There's not going to be like summative assessment and progress assessment, which have different weights assigned to them. All of the assignments are going to be of equal weight. What I decided to do for AP Computer Science A, and I will type this up in an email and send it to you. I just wanted to make sure I asked you about it first. So I'm like, here's my thought. Here's what I'm thinking for this class. Do you think it's a good idea? And if you have any feedback, let me know. So since you have the final project to do, since you do have the AP Computer Science A exam to study for, which you're hopefully doing and not just playing silly video games, but since you have all of that work to do, in the meantime, I set you up on that Code HS, which is a great Khan Academy-esque resource for you to go through the AP Computer Science A curriculum. You have a digital copy of the textbook on the classroom that you can go ahead and read through the textbook at your leisure. You have plenty of practice problems that I've provided. You can go ahead and search for practice problems and find a whole wide array of practice problems, no pun intended, but an array of practice problems for you to just work on the AP Computer Science A exam. I don't want to like bog you down with a ton of additional work on top of all the preparation that you're hopefully doing for the AP exam, which is in just about a month, by the way, a little less than a month. So what I've decided to do for our structure going forward is from our classes, or after all of our class periods that meet on Tuesdays, this being one of them, I am not going to assign you official homework to do. However, that is with the expectation that you are spending the time that would be normally done doing official homework to study for the AP exam, to work on that Code HS stuff, to work on your final project, or some combination of something related to AP Computer Science A. All right. I think that's probably pretty fair because, I know you have other classes as well. I know you guys are very busy. You have an AP exam to prepare for. So after every class period that meets on Tuesday, I am not going to assign you an official assignment to do with the expectation that you're working towards any of the other tasks that we have to complete for AP Computer Science A. However, at the end of every class period that meets on a Thursday, what I am going to do is I am going to assign you a graded assessment. Okay, what that graded assessment is going to be is, not surprisingly, because we are studying for the AP Computer Science A exam, one free response question with a topic that's relevant to the topics that will be on the AP exam. So arrays, array lists, methods, or objects are really the focus here. So you will get one free response question that you will have to complete and submit to me for a grade. Okay, and that will happen every week. That should give us a nice collection of grades before the AP exam and before the end of the fourth quarter. That should all give us a nice collection. That should also give us a nice collection of grades as you go throughout the whole quarter, so that your overall quarter four grade is not contingent on like one or two scores. There's going to be probably like 5, 6, or 7 assessments that are all going to be averaged together to account for that. Okay. For any free response question that I do assign after class on Thursday, I am going to expect it to be submitted to me by Sunday night, and Sunday night at 11:59 p.m. The reason for the Sunday deadline is so that I can spend Monday grading it and getting the feedback to you. Okay, so that's why I was thinking, let's have it due at the start of the next class on Tuesday, but then we're already behind. Then it's like, well, I don't have time to grade it and get you feedback in time for the next class, and it seems like that would be like kind of playing catch up. I think that's a very sufficient amount of time. That's Thursday afternoon plus Friday plus Saturday plus Sunday in order to get one free response question done, which should take maybe about 30 minutes or so. So I think that's more than reasonable. All right. To submit your work, what I am going to ask is that you either type it up on a Google Doc and share it with me, or if you handwrite it, you could take a picture of your handwritten work and send that to me as well. I'll put more details in an email as far as how to submit work and how that's all going to work out. All right. But does that sound like a fair plan of attack going forward, or does that seem unreasonable, or does anybody have any critique or feedback? Sound good? I take your silence
Yeah,
as
sounds good.
that's perfect. Sounds good. We got one sounds good. Can we get another sound? We got sounds good in the chat. Can we get another sounds good?
Sounds good.
All right, Nick, thank you so much. Unless anybody thinks, like, again, if you think that...
Sounds good.
Oh, whoa, what a right guy. All right, that's what I like to hear. If anybody think that it doesn't sound good or anybody has any feedback, just let me know. So that being said, I will, on this Thursday, send you your first graded assignment. It will, again, be a free response question relevant to the topics we talked about, and I'm going to ask you to submit your work to me by Sunday night. So just so we're clear on that. Okay, let's go ahead and now talk about the homework from last time. Okay, what I asked you guys to do was I asked you guys to look at the 2017 AP Computer Science A free response questions and try the first two problems, because the first two problems do have topics that are relevant to what we could see on this year's AP Computer Science A exam. So take a look at the first problem, right? What I did is I typed up my solutions here that I will share with you in a little bit. And I also tried to, again, like, my purpose of going through these with you is not just to, like, talk at you for a half hour, but it's to hopefully try and really explain my thought process as I'm working through these problems with you. Okay? It's not that, again, it's not me talking about this is how it's done. It's more of this is how I do it. If you find another strategy that works for you to organize your work, then by all means, employ your own strategy. That will only come with practice, though. You do have to make sure you practice. Okay, but here's what I generally do going forward. First, I like to just read the question, give it a good once over. It says, this question involves identifying and processing the digits of a non-negative integer. Important that you extract also a lot of key information about the problem is said in these sentences here. Non-negative means we don't have to worry about the case where we're dealing with a negative value. Declaration of the digits class is shown below. You'll write the constructor and one method for the digits class. So, public class digits. It says the list of digits for a number used to construct the problem, to construct the object. The digits appear in the list in the same order in which they appear in the original number. So we have this array list of type integer called digit list. Okay. What we're going to be doing in part A, and by the way, we start with our number greater than or equal to 0 as it's set up there, is we want to go ahead and create the constructor for the digits class. The constructor, it says it right here, initializes and fills digit list with the digits from the non-negative integer number. The elements in digit list must be integer objects representing single digits. That's easy enough to do. And appear in the same order as the digits in number. Each of the following examples shows a declaration of a digits object in the contents of digit list. So you could see that, oh, if I create a digits object here, I want digits C1 equals new digits. What should happen is this digit list array list should look like this, 1, 5, 7, 0, 4, matching that. So essentially, and by the way, if we have 0, it should just stay at 0. So essentially what the challenge is here is how do I get it so that this number, how do I get it so we can isolate the digits of these numbers, of this number, and add each of those digits to the array list in order? Well, what I started to think about is I said, well, how can I isolate the digits of numbers? Well, I can get the last number of any specific digit by doing mod 10, right? Little mod math. Taking the last digit of any number, if I did mod 10, whatever this big number is, hopefully you can see that that's going to return 4, right? 15,704 mod 10 gives us 4. That's how we isolate the last number. We can isolate the last two numbers, by the way, by doing mod 100, isolate the last 3 by doing mod 1000, and so on. But I only need to isolate that last one. I can get 4. Then what I can do is I can add 4 to the list, and then divide this number by 10 to now get down to 1570. Then I can just repeat that process again. Do mod 10 to extract 0, add 0 to the front of the list, divide the number by 10, we get down to 157. In order to get the 7 by itself, I can mod 10 to isolate the 7, add the 7 to the front of the list, divide by 10, we get 15. Again, mod 10, we get 5, divide by 10, we get 1, and then the 1 goes here. Okay? So what I did for my solution is exactly that. I said, well, what's my goal? My goal is to construct an array list filled with integers representing single digits that appear in the same order. What tools do I have to work with? So I have the number that is provided, and I have the digit list, right? We've seen in some other examples, we have a ton of tools to work from, like the mechanical arm example is a really good one, where we had like all these different methods like turn around and change direction and is facing right and all those types of things that we could use as tools. Here I only have two tools. I have number and digit list. And what are the preconditions? What are things that I don't have to worry about? Things that I can already say are true. Well, what's true at the very start is that the number is greater than or equal to 0. So that's important. We don't have to worry about negatives or anything like that. So this is the code that I came up with. Here's our constructor. Since it's a constructor, it's just called digits. We're passing in the number. The first thing I have to do is I have to initialize my digit list. So I say digit list equals new array list integer, right? Make sure we establish our array list. We then have, I had this condition for if number is equal to 0, then I just go ahead and add 0. I was inclined to do that because of this case down here, where they just pass in 0 and you just added 0, right? Another thing I guess you could do is you could say that if I'm actually thinking about it now, what about if your number is less than 10? Then couldn't you just add number, something like that, right? So that takes care of like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, where they're just single digits. I actually like that a little bit better, so I think I'm going to stick with that. Okay, we can already assume that our number is greater than 0, so that's why we don't have to put and greater than 0, or and greater than or equal to 0. Okay. Then for any other digit, for any other 2 or more digit number, we can go ahead and say while your number is not 0, let's add 0 at index 0 a new integer of the number mod 10. So that's what isolates that last digit. I can add that to the list, add it to the front of the list. Notice I'm adding it to index 0, and then we take our number and divide it by 10. And that's just going to reduce it, and add all these numbers to the list. So by the end of this, we will have digit list filled with all these integers. Does that make sense to everybody? How that's done? Okay. Part B is to now determine if digit list is strictly increasing. So going back to here, I like, again, the fact that the AP exam gives us a lot of examples to go off of. You should definitely take advantage of that fact and say, well, let's test the code that we come up with all of these examples. I think that's a really great idea. If you have some extra time while you're working on the free response, like say you finish it, go back and say, do these examples actually work with my code? But it gives us some good examples here. Strictly increasing means that if they appear in strictly increasing order, it returns true. Otherwise, it returns false. Here you should see that this is in strictly increasing order. This is not because you have 2 3s. This is not because they're mixed up, and this is not because this is strictly decreasing order, right? So I think actually I just need to change that to that. I'm noticing now that the 2 3s would not count as strictly increasing, so I actually had a less than or a greater than or equals here. We don't need that. So what I did is I said, well, let's assume that we're in strictly increasing. Oh, by the way, the goal, determine if digit list is strictly increasing. What do I have to do that? I have my list. That's all I got. I got to figure out the logic to make that work. And we know that it's initialized with some value. It has some value. It's not empty. It's not null or anything like that. So I'm assuming that it is strictly increasing. I'm going to say for int I is 1, I is less than digit list.size, I++. I'm going to say if digit list.get I, .get in value, so meaning that at index 1, is that greater than index 0? If so, that's good, right? That's what we want to have happen. Is index I, or is index 1 greater than index 0? I hope so, because that would mean it's strictly increasing. Is index 2 greater than index 1? Is index 3 greater than index 2? That's what this loop's going to do, right? I hope that they are, so that that's strictly increasing. What I did here is I said, if that's not the case. So if it's not the case where any index is not greater than the previous value, then we know we're not increasing. Okay? Of course, you could have did that instead of saying not. You could have just said, is it less than or equal to? Sure, you could have done that. But I think the not makes more sense in my mind, at least, to say, like, this is what we want to happen. So it's actually troublesome if that does not happen. That was at least my logic. Again, you could say just if it's less than or equal to, then that's bad. But either way, it's the same thing. And if that's the case, then we know we're not increasing anymore. But if we make it through the whole loop without triggering this statement, then we know that we are still increasing, so we return increasing. Does that make sense to everybody how that's done? It's almost like problem solving in a way. It's like, how do I actually solve this problem and tell a computer how to do it? That's the trick of these free response questions. They're really cool little like brain teasers. Okay? Question 2 was going on to writing a whole object, which was pretty cool. So it gave you a lot of this stuff about interfaces. Again, we didn't talk about interfaces because it's not on the AP exam. What I am going to do is, because it was cut from the AP exam, after the AP exam, I am going to spend a couple class periods talking about the content that we didn't get to that is not on the exam, because again, I think it would be a disservice if I did not at least expose you to that content so you could see it as you prepare for a college, level computer science class in the future, because it's important that you see it, and I think it's good to be exposed to it. Essentially, an interface just talks about what is required to be in a specific object. Since we have this interface called study practice, it's saying anything that uses this interface has to have this method called get problem and has to have this method called next problem. You didn't actually really need that though, because the actual information that you need to do is create this multiplication practice class. Okay? It needs to have this method and this method. Hopefully you're able to determine that information just based on how it's kind of formatted here. Okay? It even says it right here. We need to have next problem and get problem. So what you're able to say is that a multiplication practice object is constructed with two integer values, first integer and second integer. The first integer is a value that remains constant and is used as the first integer in every practice problem. That's important. The initial second integer is used as the starting value for the second integer. The second value is incremented for each additional practice problem produced by the class. For example, a multiplication practice object created with the call new mult practice 7, 3 would be used to create the first practice problem 7 times 3, then 7 times 4, then 7 times 5. That 7 staying the same, the 3 is going to increase throughout. In the multiplication practice class, the get problem method returns a string in the format of first integer times second integer. The next problem method updates the state of the multiplication practice object to the next problem. So that's exactly what it tells you these methods need to do. So you need to have this get problem method that returns a string in the form of first integer times second integer. The next problem method just increases that second integer by 1. You see a bunch of examples here, which again tells you exactly what you need to do. If you made a multiplication practice with 7, 3, and you said p1.getProblem, that should give you 7 times 3. If you said p1.nextProblem, then getProblem, it's 7 times 4. Here you can see even a couple skips where we have p2.getProblem, and then we do next problem, and now we're up to 15. Okay? So what we essentially have to do is we just have to write what that entire class looks like. If I look here, I said to myself, well, what do I have to do? I have to write a multiplication class, mult practice class that contains a constructor and two methods, get problem and next problem. What tools do I have? Well, I don't have any tools per se, but all these sample outputs and all the descriptions reveal exactly what my methods have to do, right? So that's good for me. And our preconditions is always on the AP exam that valid input is provided. All right, we don't have to worry about them inputting strings or anything like that. So the class is really just this. We have our first integer, second integer. The constructor is exactly what we've worked on in class, a ton of constructors like this, where all we're doing is if they pass in two integers, we just set these equal to those. The get problem says I want to return a string in that form. So I have my string to be first integer, the word times, and then second integer. and then I just return that string. You could have done this all in one line if you wanted to say, just to show you, return new string, first integer, and then times second integer. If you wanted to do it all in one line, you certainly could have done that. You actually don't even need the new string either. You could have actually just done this if you really wanted to. But I kind of broke it down for you just so you could see the two lines. Okay. Either way, though, I'll leave that in there just in case. And then the next problem, all that next problem method does, hopefully you're able to figure that out from over here. You're like, all it's doing is just increasing this number by 1 the whole time. That's it. So that's exactly what it does. It just takes the second integer and adds 1. All right. And that would be a good multiplication practice object. Does that make sense to everybody? And does anybody have a question on any of those things? Okay, I take your silence as sounds great. All right, so what I want to say to you is I did mention I want to talk about the final project a little bit. Again, the final project is something that is sort of looming in the background. It's something that you definitely should be working towards the whole time. Now, what I did is I did create a little section here called the final project where I have your prompt and I do have your music and image objects here. You can choose to incorporate images or music in your game if you want to. It is absolutely not necessary, and there is no bonus for doing so or penalty for not doing so. It's just if you want to jazz it up a little bit, then here you go. All right. What I am also going to provide for you is I am going to provide, I'll do that probably tomorrow, I'll get around to doing that, a couple examples of some sample games from last year and the year before that some students had worked on. All right, so you have a couple examples to go off of as you see, oh, this is about the level of complexity that's expected. Now, that being said, with distance learning being in place, and I know there's a lot of variables up in the air right now, and we have a lot less lab time to work on this, I am definitely going to temper my expectations in the sense that not that I don't expect you to produce a fantastic game of high quality, but I do know that we're under a little bit more of limitations this year, I guess is a good word for it. So I am going to adjust my expectations accordingly. All right. So don't think that you have to, like, you're going to look at some of the examples and you might be like, wow, these are really cool, which I certainly think they are really cool, but you may not have to shoot for the complexity of that necessarily. Okay. However, it is still something that you are going to be required to do. Now, since there is the policy of that all quarter 4 grades have to count for the same amount, I definitely have to adhere to that in assigning the final project. So here is what I decided to do. What I decided to do is I am going to make you guys, just to keep everybody on track, submit a proposal for the final project. I do that every year. The proposal is just one paragraph written by you and your partner if you're working with a partner, or just you if you're working independently, just describing what your game is, what the final goal of the game is, why you chose to pick the game that you went with, and the skills that you will be using along the way. Okay, so again, it's just what my game is, like a brief description of your game. How do you win? How do you lose? Things like that. What skills that your game is going to incorporate. So this game is going to rely heavily on arrays because they need to keep track of an inventory or something like that. As well as just a little explanation of why you chose to go with this genre. The reason why I want that proposal is because that gives me a good indication, are you off on a great start or are you off on not such a great start? If you propose to me that you're going to make the next huge AAA game, then I'm going to be like, that is way, way, way unreasonable and way outside the context of this class. Okay? If you propose to me that you're going to make a game of, hey, I'm thinking of a number between 1 and 10, what is it? The user inputs 5, sorry, you were wrong, game over. That's not quite complex enough for a real final project in an AP environment, all right? Certainly, because of the limitations this year, one thing I wanted to mention to you is there's nothing wrong with traditional games. If you want to make a tic-tac-toe simulator for your final project, that's a great final project. And I know we did it in class. We did a little bit of a tic-tac-toe lab. But if you want to do it with like a little computer opponent that plays tic-tac-toe, maybe that computer opponent can notice when you have 2 in a row and can try to block you. That would be really cool. Something like that. If you want to make I don't know, some sort of like a hangman type of game where you have to guess a word and you pick a letter and it fills in the missing letters, that would be a great thing. All those little traditional games, don't forget about those. Yes, you can certainly create some role-playing game where your character goes off on a quest or some murder mystery that your character has to solve. Absolutely, those are fun, engaging, and interesting. Okay, but don't forget about the simpler cases too, where you can actually end up with still a quality and engaging game, but a lot of the work, or at least a lot of the parameters, are done for you as far as what's the goal of the game, what's the design of the game, what are the rules of the game. All right, so I just want to make sure everybody's aware of that. So speaking of which, what I am going to do is I am going to require you to submit a proposal, like I said. I know that I said I wouldn't give you work after Tuesday classes, but I am going to give you a little bit of work this Tuesday just because I want that proposal in my hands. So I think it's reasonable of me to ask for a proposal to be submitted to me via email. You can just send it to me in an email by Friday, by the end of the day on Friday, so 11:59 p.m. on Friday. I think that's more than reasonable. You and your partner can work together, type 1 paragraph just to say, this is the game that I want to do, this is how you win, this is how you lose, these are the skills that are going to be incorporated, and this is why I chose to go with this game. Okay? Should take 15 minutes to put together if you already have an idea. If you don't have an idea, then it forces you to come up with an idea because, the final project is going to be due at the end of May. I know that seems like a while from now, but that is only a month away. So you got to kind of get a little moving on that. All right. The way that I'm going to grade the final project is I am going to count the proposal as 1 grade. I am going to count the final project as 2 grades. So that's a total of 3 grades for your 4th quarter are going to be dedicated to the final project. I'm going to break down a lot more for you as to how the final project will be graded as we get a little, maybe about next week, I'll try to work on some more descriptive rubrics for you as to how specifically what am I looking for in the final project as far as what I'm going to be grading. Okay? Essentially, what 1 grade is going to come down to be is, does it work properly? And the other grade is going to be, does it correctly incorporate the skills that we've used in AP Computer Science A? All right? But I'll type that out a lot more formally for you so you can see that. Alrighty. That takes us just about to the end of class. Hopefully I was able to explain these 2 free response questions in a logical way for you. Like I said, I'm not going to give you official homework for Thursday, but I am going to ask that you and your partner come up with a project proposal and submit that to me via email. You can type it up in a doc and share the doc with me, or you can just literally type it in an email, however you want to do it. But please submit it by email by Friday night so that I can look it over on Saturday and send it back and say, hey, this is a great idea. I think with a month's time, you'd have you'd be able to do this. Or I could look it over and say, hey, you only have a month to do this. I really don't know if you're going to be able to create the next big epic quest, to change gaming history. All right, so just be mindful about that. Any other questions, comments, or concerns for me as we wrap up today for AP Computer Science A? Nothing? Feeling good? Happy? Processing? Thinking? Okay. I take it that you are feeling fine. All right. So, yes, thank you. Thank you for the confirmation. Is that Andrew? Andrew, you are a gentleman and a scholar. I appreciate it. All right.
Facts.
Yes. True facts. All right. So, that's all I got for today. I do hope you have a fantastic rest of your day. I will see you on some day soon. When will I see you? Thursday. I'll see you on Thursday. All right. Thursday, I'm going to have more stuff to show you, more practice problems to go through with you, and I'll assign you one on your own to complete by Sunday night. Okay? Have a fantastic rest of your day and a great couple days until I see you again on Thursday.
See you, Giorgio.
See ya.
Giorgio.
Giorgio.
Bye, Mr.
Giorgio.
Later.
Bye, Mr. Giorgio.
Goodbye.